In this last set of notes here, we're going to talk about the normal curve. And the normal curve is when we're working with a symmetric graph, which means the mean and the median are approximately equal or are equal. And one of the things that sometimes students ask a teacher or an instructor to do is to curve, say, an exam or curve a test or curve some sort of assignment. And really what that means is that there has to be the highest number of C's and then an equal number of D's and B's, and then a smaller proportion, but also equal A's and F's. And that's probably really not what students are asking for. But that's what a normal curve, or that's what curving something means. And so we want to recall this idea of skewness. And skewness, recall that there's either right skewed, left skewed, or symmetric. And in this first graph, it looks like it is left skewed, but remember, skewness has to deal with the mean being pulled in one direction, and it's pulled because of outliers. So the smallest number of items here is on the right-hand side, and recall that the mean is greater than the median, so this is right skewed, even though pictorially it looks like it's the left, but that's not. Remember, skewness is being the mean is being pulled in a certain direction. In this case, in B, the mean is actually being pulled. So in B again, the mean is actually being pulled by this outlier in this this one outlier over here, and this time the mean is much smaller than the median, and so the mean is being pulled towards the left-hand side, so this is left skewed. Again, don't let your eyes deceive you, because it's all about which direction the mean is going. And then in this last graph, the mean and the median are the same, and we have the highest number in the middle, we have equal numbers on the right, the left and the right-hand side, and also an equal number of items on the left. And these items don't always have to be equal, but we're really looking that the mean and the median are symmetric, are the same, so this is symmetric. Okay, and so when we talk about the normal curve, we're talking about when the mean and the median are equal. When we're using large pieces of data, we can consider it closely equal. And so we know that the data is said to be symmetric, okay, and that's from looking at our histograms. And anytime we're working with a normal curve, we're always using the mean because we're talking about the standard deviations, and standard deviations are the distance from the mean, so equally spaced distances from the mean, where a box and whisker plot is spaces from the median. So the mean, and then we're going to use the population standard deviation. And we call the population standard deviation is this lowercase sigma with the little x when we're doing our calculations in our calculator. Now there's this thing called the 68, 95, 99.7 rule. And essentially it says when our data is symmetric, so when we're using this normal curve, we have 68%, so 34 and 34, so there's 68% of the data falls in this portion of our graph, okay, and this is the mean. And when we use the mean, we use the x with the bar over the top of it. And again, here's that sigma sign, which means standard deviation. So this is one standard deviation below. So this is one standard deviation below the mean. And this would be one standard deviation, two standard deviations, and three standard deviations above the mean. So I'm going to just write this here, three standard deviations above the mean. So 68% of the data falls within this section. And then our next section, if we take 13.5% plus our 68% plus another 13.5%, so within 2 standard deviations, 95% of the data falls in this section. And then within 3 standard deviations, we have just about all the data is 99.7% of the data. Remember that because the mean and the median are equal, that this mean line is also can be considered the median, and median is half. So all of the data, so there's 50% of the data would fall below the mean, and 50% of the data falls above the mean. Anytime that we're talking about what we consider to be normal is by using this graph. So the other thing to consider is anything within 95% is considered, so this is considered more normal. Anything within 95%, anything beyond 95% or beyond 2 standard deviations, either plus or minus 2 standard deviations, anything beyond this over here, anything below over here are considered outliers. So our definition of an outlier is a data value or values that is outside the norm. And norm is shortcut for normal.